So this is our recap for the inverse trigs, right? We did this yesterday. So if I know y equals the arctan of u, so that's some function of x, right? Then, and we have it memorized, y prime is u prime over 1 plus u squared. And it just seems so weird that that's it, but I derived it using the implicit, right? And then now you have to memorize it and go with it, right? You just have to memorize it and go with it. So if y equals the arcsine of u, then y prime is u prime over square root of 1 minus u squared. So same idea there. And those are pretty much the only two I give. Arc cosine and arcsine only differ by a negative. So let's just do one real quick. A nice simple one first, right? So let's say maybe let's say y equals the arcsine of x over 2. So you see my model is right above me. I'm going to make sure I have that on my formula sheet. And if you saw what I did yesterday, remember I found u prime, I found u squared, and then just plugged in, right? So u is x over 2. What's u prime? 1/2, right? It's just the slope. Is that okay? And then u squared is obviously x squared over 4. So once I have those three pieces, I'm ready for my formula now. Y prime is 1/2 over the square root of 1 minus x squared over 4. And of course we want to clean it up, right? If you looked at the answer in the book, there would not be that answer. So the key is I want a single fraction, no fractions within fractions, and it should be completely factored, right? So we can just bring out the 1/2 here first, right? And then I want to try and get rid of that 4 inside there. So I'm going to get a common denominator. And then that 4 now factors out as a what? What does the 4 factor out as? Anybody see it? Yeah, and what does the 4 factor out as? The one downstairs. A 2. So my 1/2s are going to cancel now. And there it is. Y prime is simply 1 over square roots of 4 minus x squared. So do you see what I mean about you have to accept that derivative piece and just go for it, right? You can't think too much about it. We'll do another one. And don't forget how you're checking your derivatives, right? I saw a couple of you do it on the quiz yesterday, which made me very happy. Some of you are still not checking. You don't know if you're right or not. So anytime I ask you for a tangent line, you should check it. Anytime I ask you for a derivative, you should check it, right? So one I love to put on every test is something like this. So y equals the secant of the arctan of, let's say, x squared, right? We kind of did that one yesterday. But what is the inverse trig? What is an inverse trig? in geometry, what is an inverse trig? Well, what's a trig? Okay, the trig is a ratio of two sides of a right triangle, right? And no matter how big the triangle is, if the angle is the same, the ratio is the same, right? It's that special, so special, right? Even known by the ancient Egyptians that, hey, we better give this a special name. Sine, cosine, tangent, right? Et cetera, et cetera. So, but what is an inverse trig? If I know a trig is a ratio of sides of a right triangle, what's the inverse trig? What's that? No. What is it? No. One side? No. It's the angle. It's theta. So meaning I could say here theta is the arctan of x squared. But I don't think in terms of inverse trigs, I think in terms of trigs. So what can I say next? I don't think in terms of arctans. I think in terms of tangents. So what can I say on my very next line? What's that? Yes, secant theta. Yes, the problem turns into secant theta, but I don't want to think in terms of inverse trigs. I want to think in terms of trigs. So instead of me saying theta is arctan of x squared, what can I say? Tangent of theta is x squared. Once I have that, I have a picture. Once I have this piece, I have a picture of my triangle, my value of theta. This is x squared, this is 1, this is square root of 1 plus x to the fourth. I'm doing that with Pythagorean theorem. Ethan? Tangent is the inverse function of arctan. So if I actually take the tangent of both sides, tangent and arctan cancel each other out. Yes, that's right. So yeah, I like you saying this is now really the problem is y equals secant of theta. I want the derivative, right? So how do I get the derivative? Well, derivative of the outside function is you're killing me. You're killing me. Secant is the outside function. What's the derivative of secant? Secant theta tangent theta times what? Times theta prime, right? I got to do the derivative of the inside. Well, guess what? That's the arctan, right? So I need the derivative of the arctan of x squared. Again, notice I'm putting that placeholder in so I could say a whole sentence, right? I've got a complete thought there on that line. What do I have to do to find the derivative of arctan? I need u prime, I need u squared, correct? So u is x squared, u prime is 2x, and then u squared is x to the fourth. So now I have y prime equals secant theta, tan of theta, and then what, 2x over 1 plus x to the fourth. How we doing? Well, I have two trigs there, right? I have two trigs there, but I have a triangle. So I know what secant is, right? And I know what tangent is. So secant is 1 over the square root of 1 plus x to the fourth. Tangent is just x squared. And I still have my arctan derivative here of 2x over 1 plus x to the fourth. Everybody with me? I got the secant from the triangle, right? Secant of theta. Or somebody, yeah? Yes. It is. Theta is still that arctan x squared. But what I really want to do is, because I'm asking for trigs now, I want ratios of sides. So when I'm looking at the secant, it's the ratio of these two sides, right? And tangent's the ratio of these two sides. So I'm putting that into my derivative. Whenever you can, simplify, right? So it looks like I get what? 2x cubed over 1 plus x to the fourth to what power? Oh, this is an x to the fourth, sorry. To the 3/2 power. Right? Half power plus a whole power, right? A to the half times a to the 1 is a to the 1/2 times a to the 2/2. So it's a to the 3/2. Nice, everybody's here. So just back to my outline for today. If you still have homework questions for me, I'm happy to answer. Your new homework is posted, and you're almost ready to do it all. I have another day I need probably. I've got exam 1 scheduled not for this Thursday, but for next Thursday. And then I'm just doing my recap. So I just started at the inverse trigs here. Nice. Do you want to grab one from the book? Should we do one from the book? In inverse trigs? Yes, it is. Oh yeah, we did that horrible one yesterday. Let's do 25. Arctan of the cosine of theta. So we've got y equals, oops, let me go to a new page. So this is 3.6, number 25. Y equals the arctan of the cos of theta. A little strange, but we know we're going to have to take a derivative of an arctan, right? And we're going to have to find a value of u, right? Because we have this one memorized. Y equals the arctan of u gives me y prime equals u prime over 1 plus u squared. So all I have to do here is figure out what the function u is. And of course we know it's cosine of theta, right? What's the derivative? What's u prime? Yep, negative sine of theta. And what's u squared? That's cos squared theta. Pretty easy, right? Say yes. Thank you. So now our derivative, y equals, so the arctan derivative just comes from what I'm done almost, right? I need my my u prime on top, and underneath I need the square root of 1 minus cos squared theta. It's in the formula. Oh no, you're right. Sorry. Thank you. 1 plus, right? Yeah, sorry. And there's nothing else I can do here. It'd be nice if I could, but there's nothing else really for me to do. Let's take a look at another one. '27 is kind of nice. Yes. Yeah, and we can look at that. And that's I know there's a little worry with the nest, right? With the box, with the cat, with the mouse, right? We're worried about that a little bit. But if it was y equals arctan of cos of 2 theta, again I get u is cos of 2 theta, right? And then u prime is going to give me negative 2 sine of 2 theta, right? I get the derivative of cosine as negative sine, keep the cat in the box, and then take the derivative of what's inside. I get that's where the 2 comes from, right? So not much changes. Let's do 27. So I've got y equals x inverse sine of x plus the square root of 1 minus x squared. Inverse sine and arc sine are the same thing, just pronounced differently. So I need product rule here, right? So my first function is x. The derivative of that is 1. The second function is inverse sine, and the derivative of that is 1 over square roots of 1 minus x squared. Have it memorized. And I'm doing a product loop. Everybody with me? Yeah, Ethan? Because I see I have an x times an arc sine, x. So I have a product of functions. Why it's not a problem, right? If I have a product of functions, I need to use a product rule. So what do I get for y prime? I get x over square root of 1 minus x squared plus arc sine, right? Now I'm taking the derivative of this piece up here. I haven't touched that yet, but that's just a square root function. So I get plus 1 over 2 square roots of 1 minus x squared times another 2x. Ooh, negative 2x. Yeah, where are you? Yep, no problem. Yeah. But in my loop, right? Product loop, I get an arcsine function, right?
What's our concept is sine what?
Arcsine, no, arcsine, it's arcsine of x. When I'm doing a product loop, right? Just like I did it last week, I set up my first function and my second function, right? Then I take my derivatives and then I do the loop part. So this in green is me doing the derivative of the first function. And then in black is me doing the derivative here of that second function. Question?
Can you just write that second one out?
Yeah, it's a square root. So derivative of a square root is 1 over 2 square roots. Keep the same thing inside, and then take the derivative of the inside. What's the derivative of the inside here? One minus x squared. What's the derivative of that? Negative 2x. So that's chain rule. Right? Square root function, right? So we have this memorized. If y is the square root of x, y prime is 1 over 2 square roots of x, right? But in this particular one, I have a complicated inside. Question?
So for our thing, we have u over 1 plus or u prime. That function, right? For
For arctan, yes. This
arcsine.
arcsine is, I put it on that first page, right? Right here.
So we're not using, are we not using that for this?
I did. So do we agree that I have a product rule? Okay. So I'm doing a product rule. I take the first function, x, and its derivative, 1. Then the second function, arcsine, and its derivative. Notice I got the derivative here. Right? And then I use the loop part of what I want. And I got that in green here. Then I'm taking the rest of the function. Rest of the function is, I need to still take the derivative of this part. That's a square root. So 1 over 2 square roots. Keep what's inside. And then the derivative of the inside. Chain rule.
Is there a formula for arc also?
Yes, it's just the opposite of the derivative of arcsine.
Opposite of
Negative, yep. So look at what I have here. Notice I've got an x over square root of 1 minus x squared, and then I've got a minus x over square root of 1 minus x squared, and then I have an inverse sine of x. So these go away. Final answer, inverse sine of x. It's right around here where you just get completely overwhelmed, and if you don't have the chain rule down, you're toast, right? So you gotta make sure that that you can think about everything.
X minus 2x.
But the twos cancel, right? Yeah.
With y minus
Derivative of the inside. If y equals 1 minus x squared, y prime is negative 2x.
Well, that's the big part. For the arcsine, we automatically use the u function, and then this one is no.
Yes, I did. Well, it was a really simple inverse trig. It wasn't complicated. So u is x, right? U prime is 1. Yeah. So I did do that, but it's so easy, I just went right to the formula. Another? Yes? Let's do, this is number 19. It says, y is the arc sine of 2x plus 1. Obviously, this is the one where I need u, right? So u is 2x plus 1. I need u prime. That's just 2. We agree? Yep. And I need u squared, but I'm not going to square it yet because I don't know if I need to. I'm going to wait. Right? So y prime is u prime, that's 2, over the square root of 1 minus u squared. It looks like I might need to FOIL that out. Watch out for that negative. Not much happens, just the ones go away, right? So 2 over square root of negative, and it looks like I can factor, but I could factor out a negative 4x there, but not that important for me to do it. I can factor out a 4, though. Do you see that? So the 4 comes out as a 2, right? I took the 4, factored it out of the square root, it's 2. Say again? Square root of 4? 2, yeah. I'll write it this way first. I've got the square root of 4 times negative x squared minus x, right? You can see that. And then the square root of 4 is just 2. Yeah. So final answer, 1 over square roots of negative x squared minus x. So yeah, they're confusing, right? They're not easy, but you got a pattern and you got to just try and go for it. Yeah, question.
If it was the sine 2x plus 1, you would do the cumulative, right? But
Yeah,
you don't necessarily need to follow that path because you already have the formula.
exactly. So that's what I'm saying to you. It seems weird that all right, we created this formula uh, for the inverse trigs, right? And the formula has that chain rule built into it, right? All right, so we talked about our inverse trigs. Let's do some implicit, okay? Let's do some implicit and see how we do. So we're going to recap implicit differentiation. So like I might have sine of x plus y is equal to x, right? We saw a tangent like this one yesterday. I want to find the derivative. I want to find y prime in terms of x. So first of all, if I have a trig, what do I have? A triangle. Yep, right triangle. And I know the ratio of sine is opposite over hypotenuse, right? And my remaining side is by Pythagorean theorem, square root of 1 minus x squared. If I have a trig, I have a triangle. If I have an inverse trig, what do I have? If I have an inverse trig, what do I have? A what? An angle, which means I have a trig, which means I have a triangle, right? I won't always need it, but most of the time I do. All right, derivative. What's the derivative of sine? Good, so I get cosine of x plus y times what? 1 plus y prime, nice. And that's equal to 1, right? I took the derivative of both sides there, right? I'm solving this for y prime, so I get 1 plus y prime equals 1 over the cos of x plus y. And so it looks like I get y prime is secant of x plus y minus 1. But I want to go to my secant in my triangle, right? And get this ratio. Yes? So y prime is 1 over square roots of 1 minus x squared minus 1. I mean, in this particular case, this is a acceptable answer. You could still get a single fraction, but it doesn't simplify that well. So this would be the single fraction answer. And of course, from a computer science standpoint, I like the first answer better, just shorter. You see what I did to go from that last? Yeah. Yep. Everyone okay here? Okay, where? So 1, 2, 3, 4. Yeah, 3, I used the triangle. I got the secant of theta. Let's do another implicit. Let's work on 27 here. So I have 2 parenthesis x squared plus y squared quantity squared equals 25 x squared minus y squared, and we have the point 3 comma 1. So let's put this into Desmos. And I know you're probably waiting for me to show that screen again, but here it is. 2 times parenthesis x squared plus y squared that entire quantity squared is equal to 25 times x squared minus y squared. Beautiful. And we should have the 0.31. Of course, I could verify if I plugged in all the x's as 3's and all the y's as 1, I would get an equal, right? You agree with that? You agree with that? So 2 times 3 squared plus 1 squared equals 25 times 3 squared minus 1 squared. Yeah, so 200, right? Yep, 200 equals 200, yes?
Okay.
Yeah, I just checking the point. I mean, obviously I can see it works, but you want to verify too. Now, what do we want? We want the tangent line at 3, 1, right? So I'm going to have to take all of this and get my derivative, right? So I want d dx of 2 times parenthesis x squared plus y squared quantity squared should equal d dx of 25 times x squared minus y squared. Good. Somebody help me on the left side. Well, the 2 is just going to come for the ride, but then I get times another 2, that's from my exponent, right, of x squared plus y squared, times the derivative of the inside, which is 2x plus 2y y prime. Make sure you see that. The 2 came down as a power, right? The power came down as a multiplier. I keep the inside as it was, but now it's to the first power, and then the derivative of the inside, 2x plus 2y y prime. Did I do the chain rule on this piece? When I got that derivative, did I do the chain rule there? Yeah, I always do the chain rule. Derivative of the inside is 1, so I don't bother writing it, right? Right-hand side, what do I get? 25 times 2x, right, because I'm doing derivatives, minus 2y y prime. This, to find a y prime here is not that easy. So we could cheat it and just say, well, let's not find y prime. Let's just plug in all our x's as 3 and all our y's as 1 and see what we end up with, right? So I get 4 times what? 9 plus 1 times, right, 2 times 3 plus 2 times 1 y prime equals 25, and then 2 times 3 minus 2 times 1 y prime. So I'm just putting all my numbers in and see what I have left at the end. Yes? So the product that I have is with a constant, and so I don't have to bother. Constants just go for the ride. If you actually did the product rule there, you would still see the same result. It's just you're wasting your time. If it's not a function of x, you know, things should be quicker. So what do I have here? 40, and then 6 plus 2y prime equals 25, and then 6 minus 2y prime. Remember, we're trying to get y prime, right? So it looks like I have no choice. I have to distribute here. 240 plus 80y prime equals, help me, 150 minus 50y prime. I'm going to move my y primes to the left. And then my numbers to the right. Is that right? Negative 90? So I got my slope. Yep. When I took a derivative, coefficients go for the ride. Everything look okay?
So does that mean that the line is
So definitely negative slope, right?
oh, that's just this.
Yeah, that's just the slope, right? Let's get the equation now. So y minus 1 equals negative 9/13 times x minus 3. And then we plot our line. Y equals negative 9 divided by 13 times x plus 40 over 13. Love it. Yeah, question. Yeah, so I will, with especially with this implicit, I will tell you solve for y prime or don't, or just find a slope. So slope is a number, right? At a particular point for the derivative. The derivative is the slope everywhere, right? So I will tell you, find a nice looking derivative or just find me the slope at that point. Oh, it's pretty nasty. I'll do it. So right here, sorry, right here, I'd have to distribute everything. Well, that's what I'm saying. I didn't want to do that here, but this one, it would be kind of cruel for me to ask you to do it. Okay. But you clearly see I have to get this guy out and this guy out, and the only way to do it is to distribute. So, but it gets really ugly really, really fast. Let's take a look at one that maybe doesn't get so ugly. 13 does too. Let's do 13. So this is, I'll write it down for you. 3.5, number 13. and I have e to the x over y equals x minus y.
So this is that one you can't just like get y by itself.
Exactly. When I can get it to say y equals a function of x, that's explicit. We've been doing that, right? Most of our mathematical lives, all of it up to this point. This one I can't get y by itself, right? How could I possibly get y by itself here? Well, I have to get the y out of the exponent, right? So I could go ln of e to the x over y equals ln of x minus y, right? And so what happens now, I get x over y equals the ln of x minus y, and what's the problem? Now the y, before the y was trapped as an exponent of an exponential function, now it's trapped inside the argument of a natural log function. So I'll never get it out, right? I'll never be able to get it to escape, to get it to say y equals. So we, in that case, we go with implicit. And I think we can get a pretty decent looking slope on this one, a derivative. So we're going to do d dx of the left side equals d dx of the right side. Well, that's kind of, the right side's easy, right? What's the right side going to give me? Yeah, 1 minus y prime, exactly. The right side, I have to do e to the x over y, that's the derivative of the outside evaluated at the inside, times the derivative of the inside, which is x over y prime. So I've got to work on that, and obviously as what rule?
So what's the inside without that one?
E to the x, right? The input goes in here. It's like, for me, it's like the soda machine, the coin slot, right? That's where I'm thinking the inside of that function is. So what do we need here? This is the only piece I haven't done yet, right? Quotient rule, nice. So upstairs function is x, derivative is 1. Downstairs function is y, derivative is y prime, and I need the downstairs squared for the quotient rule. So I have e to the x over y times what? Y minus xy prime all over y squared, double check me there, is equal to 1 minus y prime. We agree with that quotient rule? This one not as bad to get y prime, but I'm still going to have to distribute here. Is everybody okay? So I'm going to distribute, right, the y and the xy prime all with the y squared. So I get y over y squared times e to the x over y minus xy prime over y squared e to the x over y equals 1 minus y prime. So I just distributed, right? And kept the y squared underneath each term, right? Everybody okay? Nice. I could simplify, and I also want to get y primes on one side, right? So I'm going to bring my y prime term from the left over to the right. And move my other term over, and I cancel one of the y's. You okay? So I moved this guy over here, it became positive, and I moved this guy over here, it became negative, and I canceled one y, right? Yeah. Okay. Good, I can factor out a y prime now. And divide. And then I ask you, are we done? The answer is yes or no. No. I want to clear fractions, right? So I've got a y squared. Clearing fractions. Yeah, y squared over itself. LCD over itself. Say again? Yeah, so, but y and y squared have an LCD of y squared. I could use y cubed, but just makes me work more. This is a pretty darn good answer. But of course, we already knew that e to the x over y was x minus y. So I could make that substitution as well. Is that right? Yeah, x minus y. But it doesn't get any better. What's that? When I multiplied in by the y squared.
Oh,
So the book could have either of those answers. I would say to you, write the derivative in terms of x and y only. No e to the x, right? No powers of e. Yeah. No. Yep. Mm-hmm. Yeah, you're talking about right here, right? On line 2. So am I looking at the right spot? Yeah. So I mean, I'm just doing arithmetic here. I mean, algebra. So you don't have to follow my process. You can do your own, right? Clearly, there's definitely an e to the x over y squared that has to be there, right? And then I'm distributing the other terms. That's the easier way to think of it, I think. Uh, yeah, so I moved this guy over, became positive, and I moved this one over and it became negative. Oh, 4 and 5, sorry. 4 and 5? What should be negative? Uh, yeah, I took this and divided it. So it went downstairs. Yep. Yeah, it's pretty complicated, right? The algebra. Yes, the calculus easy. Calculus is easy. The algebra is not easy. Nice. I think I need for our next section. I need implicit again. So this is 3.7, and we're going to be talking about the ln trick and the derivative of y equals ln of x. Or better yet, y equals ln of u. Right? Well, maybe I don't want to think, I mean, I know the answer, right? I know the derivative is 1 over x, but I just told you that. But what if I didn't know that it was just 1 over x, right? So let's take this one and rewrite it as what? E to the y equals e to the ln of x. What happens on the right? Yeah, just get an x, right? Those are inverse functions. And now if I take my derivatives, so d dx of e to the y equals d dx of x, I get e to the y prime on the left, and on the right I get a 1. Do we agree with that? E to the ln of x, those are inverse functions, so they cancel each other out. So I get y prime is 1 over e to the y, but what is e to the y? X. So there it is. So proving to you, right, that my derivative of ln of x is 1 over x. We want to generalize it and say what? Y equals the ln of u implies y prime is 1 over u times u prime. So this is our formula going on our formula sheet. Running out of room? You running out of room on your formula sheet? Should. Remember, I can shrink things down if you send them to me. Okay, textbook. What looks good? I will only do ln, so I won't do log base 10 or log base 2 or log base 5, only ln's. Okay, let's do 13. Ln of x square roots of x squared minus 1. It's 3.7, number 13. square roots of x squared minus 1. So, remember my formula, right? If y equals the ln of u, then y prime is u prime over u. So, pretty easy here. I know y prime is going to be the derivative of this piece, so I'm putting it in a prime over that piece. And what do I need for that upstairs derivative? Product rule. First function is x, derivative is 1. Second function is x square root of x squared minus 1, derivative is 1 over 2 of those square roots, times another 2x. Say it again. And then derivative of the inside. Oh yeah, the 2's are going to cancel, yeah. So my product is going to give me what? X squared over square root of x squared minus 1 plus square root of x squared minus 1. All over that denominator, the original denominator. Am I done? Nope. I have fractions within fractions, so I'm going to clear, right, with the LCD. Over itself. So I'm keeping the black and distributing in with purple. The first case they cancel, and then in the other two cases I just removed the square root, right? Square root times itself is just that inside. So I get 2x squared minus 1 all over x times x squared minus 1. There it is. Yep. Tell me a line if you need me to zoom. It's not bad, right? Let's look at number 37. Can I move on? We are right? Yeah, where? Yeah, so product rule here. right? I'm taking this as my first function, and this is my second function.
The square root is
1 over 2 square roots,
is that different?
and then, yeah, and then derivative of the inside, which is 2x.
Take down the square root of x to be 1 over 2 square root.
Mm-hmm. Absolutely. Where? The final answer? Yeah. Yeah, exactly. So that's my LCD. So I use that over itself to multiply by 1. And then the first square root cancels, right? And the other one's just, it's just like squaring it, right?
Like the x squared over x squared that doesn't the denominator.
No. All right, this is number 37. And I have a function x to the x, and I have no idea how to deal with it, right? I have no idea what to do. How could I get this derivative? Well, is it a power rule? The power would have to be a number, right? Is it an exponential? The base would have to be a number. So I've got a base as a variable and an exponent as a variable. So this is hard to deal with. Give me a good x value here. 2, yeah. So if x is 2, y is 2 to the 2 is 4. So 2 comma 4 is a point on my curve. Let's go to Desmos. So what do you think? How are we going to get this? If I'm going to get a tangent line here, I'm going to have to get a slope, right? Yes? So what do you think? This is called the ln trick. We're going to take the ln of both sides. What happens on the right side? It becomes that power comes down as a coefficient now, right? That's properties of our logs. So now I could take a derivative and use a product rule on the right. What do I get on the left? d dx of an ln of y. What do I get on the left? Y prime over? Good. On the right, I need a product rule. X and 1 is my first function. ln of x and 1 over x is my second function. Yeah, x times 1 over x. Yeah, x over x. Derivative of x is 1. Derivative of ln is 1 over x, and then I do my product loop, right? There's a pretty good version of the derivative. Of course, we want to find the slope at 2, right? Yep. Say again.
Why can't we use chain rule?
Yeah, we always use the chain rule, but the chain rule says nothing about how do you deal with an exponent, a variable raised to a variable. Chain rule just says something about inside and outside, right? Yeah, that's the thing. Is we can't even kind of say what's the outside function, what's the inside function. It's like there's 2 insides and 2 outsides. It's weird. X to the x.
Yeah, if it was x squared,
Then we use a power rule.
what would be x
The outside function is the squaring function.
squared?
Yeah, x squared.
So why is the outside not x?
It is, but I don't know. We don't have any rules for it. So what someone figured out is that if you apply the ln function, you can get that exponent down, and it's a lot easier to deal with. Well, this is not the prettiest looking slope, but it's what I have, right? So let me cheat a little bit. And go ahead. Yep. Just let me put this in real quick. So y minus 4 equals, what did I have? 4 plus ln of 16? Times x minus 2. So there it is. There's the tangent line. Not the prettiest looking answer, but it's okay. So the 4 outside of the ln is a coefficient. That becomes a power inside of the ln. So 4 ln of 2 becomes ln of 2 to the 4th. 2 to the 4th is 16. 2, 4, 8, 16, yes. 2 to the 4th is, where did I get a 14 from? It's a 4, isn't it? I don't know where the hell I got a 14 from, sorry. Yeah. What's kind of nice is that you could use the ln trick on a problem like we had yesterday. Let's take a look at one. I want to go to my chapter 3 quizzes. So number 2 here, we could do number 2 that way too. So let me write this for you. So I've got y equals x squared minus x to the third times 2x minus 1 to the second. We did this one yesterday, but we can do it with the ln trick. So ln of y should equal ln of all of this, right? But what happens when I have, remember the property? What's the property of ln of a times b? What does it become? Ln of a plus ln of b, right? So now I have ln of y equals the ln of my first product plus the ln of the second product. And then what happens now? More about our pre-calculus knowledge here. Anything else can be simplified? Yep. So I get ln of y equals 3 times the ln of x squared minus x plus 2 times the ln of 2x minus 1. Now I can do my derivatives. Now I finally do my derivatives. So what do I get on the left when I take a derivative? Nice, y prime over y. And remember, I need the derivative of the inside over the inside. So 3 times 2x minus 1, that's the derivative of the inside over the inside, plus 2 times 2 over the inside, 2x minus 1. I'm doing derivatives of ln's, right? And when I do a derivative of ln, I need the inside prime over the inside. So the inside prime is 2x minus 1 over the inside. And the derivative of this one, 2. So derivative of the inside over the inside. So y prime, I'm distributing the y now. I get 3y times 2x minus 1 over x squared minus x plus 4y over 2x minus 1. Yep. So we want a single factored fraction, and we already know what y is, so we're going to put y in now, right? Third power and second power, right? Yes. Yeah, you can do your algebra any way you want, right? You don't have to do your algebra exactly as I do it. Say again? Oh, you're right. I lost it. You're right. So that should be a third power now. Thank you. Yeah, pretty hideous, huh? And then finally to factoring. Yuck. And at this point, you can see it. We're getting to the same answer as yesterday. And that last one factors just like yesterday. I don't remember. Yeah. I mean, look at this. When did my calculus stop? When did the calculus stop? Yeah. There's only one line where I was actually taking derivatives, and the rest is algebra. Knowledge of pre-calculus, and then algebraic manipulation. And I didn't finish because I'm too lazy to factor that one again. Yeah. I can't leave it undone. Sorry. 16x squared minus 16x plus 3, 4 and 12, right? There it is. Oh, great. I'm going to tell you on the test if I want you to use it, I'm going to tell you to use it. But it's basically when you have exponents, it will work. Um, Whenever you have exponents, it will work. I mean, it'd be silly, right? If I had this problem, y equals x squared, right? We already know y prime is 2x, right? But if I did take the ln here, right? I get ln of y equals 2 times ln of x. And when I take my derivative, what do I get? I get y prime over y equals 2 times 1 over x, right? So y prime equals 2y over x, but y is x squared, right? It's silly, right? So I still get the 2x. So ln trick works when you have exponents. But if we already know what the derivative is, don't make it more complicated, right? Well, guess what? We're done with chapter 3. We've done everything in that I want to do in chapter 3. So we'll talk about the project tomorrow, right? And then I think I want to do the review Thursday. So tomorrow we'll talk about the project, and then Thursday we'll do our review for the test for next week. So that way you have this weekend to study for the test. And then Monday, Tuesday, Wednesday we'll be working on chapter 4. So how we're going to do the review is going to be, I'm going to give you a test, and we're going to just work on it together. I'm going to give you a test about the length of what you expect. You'll work on it, and we'll go over answers, right? But you'll get to experience it on your own. If you're not here, make sure you email me so I can get you the test and the answers. I'm going to review Thursday. Don't blow off the homework and the project. They're total of 30% of your grade. So meaning, unless you had a perfect score on all tests and quizzes, right, you'd have a grade less than 70 if you don't do the homework and the project. I think, yeah, so I didn't get to it's too much to do, right? Don't you agree? But the logs are pretty easy. The last few sections are easy if you accept the derivative rule, right? Don't fight it. Make sure you have it written down. You have a problem, you should say, oh, I know I need this formula for this problem, right? I got an inverse trig here, or I have a natural log here, right? Questions for me? We don't have a quiz today. I think chain rule would be a good quiz on Wednesday. Chain rule, and then implicit on Thursday. So chain rule quiz tomorrow. Implicit on Thursday. No quiz today because Robert's going to sneak out. Oops, I'm recording. Say again? Thursday. A review is Thursday next week. So why am I doing that? The chapter 4 that we're going to be learning won't hurt us for the test. It's just more derivatives, and then it gives me the weekend to grade it as opposed to just one night to grade it. Say again. Yes, right here, right? Exam 1 is scheduled for 8/4. That's next Thursday, not this Thursday. This Thursday, I'm going to do the review. That way you have a weekend to study. That way you have a whole week to study, but better yet, a weekend, right? How are you going to get ready for the test? You're going to take all of my old tests and do them, the chapter 2 test, the chapter 3 test, the midterm exams, right? You're going to look at every problem I have there in the chapter 2 folder, chapter 3 folder. And I have a midterm exam folder too, right? So lots to look at, lots to do. All right, let's quit here for today. You've got lots to practice.